Welcome to Slothful Slumber, the podcast where we transform the vast knowledge of the internet into a gentle lullaby for your mind. I'm your host, Luna Dreamwell, and I'm here to guide you on a journey to tranquility through the soothing cadence of Wikipedia articles. Each episode will delve into the most wonderfully mundane and sleep-inducing topics, helping you drift off into a realm of serene dreams. So find your comfortable space, close your eyes, and let the dull hum of information carry you into a restful slumber. Now, let's embark on tonight's voyage of tranquil learning as we explore a topic so peacefully uneventful, it just might whisk you away to the land of dreams. This is the final part of the Wikipedia article titled Earth. Let's continue reading about Earth-Moon System. Hydrosphere. Earth's hydrosphere is the sum of Earth's water and its distribution. Most of Earth's hydrosphere consists of Earth's global ocean. Nevertheless, Earth's hydrosphere also consists of water in the atmosphere and on land, including clouds, inland seas, lakes, rivers, and underground waters, down to a depth of 2,000 meters, 6,600 feet. The mass of the oceans is approximately 1.35 by 10 to the 18 metric tons, or about 1/4,400th of Earth's total mass. The oceans cover an area of 361.8 million square kilometers, 139.7 million square miles, with a mean depth of 3,682 meters, 12,080 feet, resulting in an estimated volume of 1.332 billion cubic kilometers, 320 million cubic miles. If all of Earth's crustal surface were at the same elevation as a smooth sphere, the depth of the resulting world ocean would be 2.7 to 2.8 kilometers, 1.68 to 1.74 miles. About 97.5% of the water is saline. The remaining 2.5% is fresh water. Most fresh water, about 68.7%, is present as ice in ice caps and glaciers. The remaining 30% is groundwater, 1% surface water, covering only 2.8% of Earth's land, and other small forms of freshwater deposits, such as permafrost, water vapor in the atmosphere, biological binding, etc. In Earth's coldest regions, snow survives over the summer and changes into ice. This accumulated snow and ice eventually forms into glaciers, bodies of ice that flow under the influence of their own gravity. Alpine glaciers form in mountainous areas, whereas vast ice sheets form over land in polar regions. The flow of glaciers erodes the surface, changing it dramatically, with the formation of U-shaped valleys and other landforms. Sea ice in the Arctic covers an area about as big as the United States, although it is quickly retreating as a consequence of climate change. The average salinity of Earth's oceans is about 35 grams of salt per kilogram of seawater, 3.5% salt. Most of this salt was released from volcanic activity or extracted from cool igneous rocks. The oceans are also a reservoir of dissolved atmospheric gases, which are essential for the survival of many aquatic life forms. Seawater has an important influence on the world's climate, with the oceans acting as a large heat reservoir. Shifts in the oceanic temperature distribution can cause significant weather shifts, such as the El Niño Southern Oscillation. The abundance of water, particularly liquid water, on Earth's surface is a unique feature that distinguishes it from other planets in the solar system. Solar system planets with considerable atmospheres do partly host atmospheric water vapor, but they lack surface conditions for stable surface water. Despite some moons showing signs of large reservoirs of extraterrestrial liquid water, with possibly even more volume than Earth's ocean, all of them are large bodies of water under a kilometer's thick frozen surface layer. Atmosphere. The atmospheric pressure at Earth's sea level averages 101.325 kilopascals, 14.696 psi, with a scale height of about 8.5 kilometers, 5.3 miles. A dry atmosphere is composed of 78.084% nitrogen, 20.946% oxygen, 0.934% argon, and trace amounts of carbon dioxide and other gaseous molecules. Water vapor content varies between 0.01% and 4%, but averages about 1%. Clouds cover around 2/3 of Earth's surface, more so over oceans than land. The height of the troposphere varies with latitude, ranging between 8 kilometers, 5 miles, at the poles to 17 kilometers, 11 miles, at the equator, with some variation resulting from weather and seasonal factors. Earth's biosphere has significantly altered its atmosphere. Oxygenic photosynthesis evolved 2.7 billion years ago, forming the primarily nitrogen-oxygen atmosphere of today. This change enabled the proliferation of aerobic organisms and, indirectly, the formation of the ozone layer due to the subsequent conversion of atmospheric O2 into O3. The ozone layer blocks ultraviolet solar radiation, permitting life on land. Other atmospheric functions important to life include transporting water vapor, providing useful gases, causing small meteors to burn up before they strike the surface, and moderating temperature. This last phenomenon is the greenhouse effect. Trace molecules within the atmosphere serve to capture thermal energy emitted from the surface, thereby raising the average temperature. Water vapor, carbon dioxide, methane, nitrous oxide, and ozone are the primary greenhouse gases in the atmosphere. Without this heat retention effect, the average surface temperature would be minus 18 degrees Celsius, 0 degrees Fahrenheit, in contrast to the current plus 15 degrees C, 59 degrees Fahrenheit, and life on Earth probably would not exist in its current form. Weather and climate. Earth's atmosphere has no definite boundary, gradually becoming thinner and fading into outer space. 3/4 of the atmosphere's mass is contained within the first 11 kilometers, 6.8 miles, of the surface. This lowest layer is called the troposphere. Energy from the sun heats this layer and the surface below, causing expansion of the air. This lower density air then rises and is replaced by cooler, higher density air. The result is atmospheric circulation that drives the weather and climate through redistribution of thermal energy. The primary atmospheric circulation bands consist of the trade winds in the equatorial region below 30 degrees latitude and the westerlies in the mid-latitudes between 30 degrees and 60 degrees. Ocean heat content and currents are also important factors in determining climate, particularly the thermohaline circulation that distributes thermal energy from the equatorial oceans to the polar regions. Earth receives 1361 watts per meter squared of solar irradiance. The amount of solar energy that reaches Earth's surface decreases with increasing latitude. At higher latitudes, the sunlight reaches the surface at lower angles, and it must pass through thicker columns of the atmosphere. As a result, the mean annual air temperature at sea level decreases by about 0.4 degrees Celsius, 0.7 degrees Fahrenheit, per degree of latitude from the equator. Earth's surface can be subdivided into specific latitudinal belts of approximately homogeneous climate. Ranging from the equator to the polar regions, these are the tropical or equatorial, subtropical, temperate, and polar climates. Further factors that affect a location's climates are its proximity to oceans, the oceanic and atmospheric circulation, and topology. Places close to oceans typically have colder summers and warmer winters, due to the fact that oceans can store large amounts of heat. The wind transports the cold or the heat of the ocean to the land. Atmospheric circulation also plays an important role. San Francisco and Washington, D.C. are both coastal cities at about the same latitude. San Francisco's climate is significantly more moderate as the prevailing wind direction is from sea to land. Finally, temperatures decrease with height, causing mountainous areas to be colder than low-lying areas. Water vapor generated through surface evaporation is transported by circulatory patterns in the atmosphere. When atmospheric conditions permit an uplift of warm, humid air, this water condenses and falls to the surface as precipitation. Most of the water is then transported to lower elevations by river systems and usually returned to the oceans or deposited into lakes. This water cycle is a vital mechanism for supporting life on land and is a primary factor in the erosion of surface features over geological periods. Precipitation patterns vary widely, ranging from several meters of water per year to less than a millimeter. Atmospheric circulation, topographic features, and temperature differences determine the average precipitation that falls in each region. The commonly used Köppen climate classification system has 5 broad groups: humid tropics, arid, humid middle latitudes, continental, and cold polar, which are further divided into more specific subtypes. The Köppen system rates regions based on observed temperature and precipitation. Surface air temperature can rise to around 55 degrees Celsius, 131 degrees Fahrenheit, in hot deserts, such as Death Valley, and can fall as low as 89 degrees C, 128 degree F, in Antarctica. Upper atmosphere. The upper atmosphere, the atmosphere above the troposphere, is usually divided into the stratosphere, mesosphere, and thermosphere. Each layer has a different lapse rate, defining the rate of change in temperature with height. Beyond these, the exosphere thins out into the magnetosphere, where the geomagnetic fields interact with the solar wind. Within the stratosphere is the ozone layer, a component that partially shields the surface from ultraviolet light and thus is important for life on Earth. The Kármán line, defined as 100 kilometers, 62 miles, above Earth's surface, is a working definition for the boundary between the atmosphere and outer space. Thermal energy causes some of the molecules at the outer edge of the atmosphere to increase their velocity to the point where they can escape from Earth's gravity. This causes a slow but steady loss of the atmosphere into space. Because unfixed hydrogen has a low molecular mass, it can achieve escape velocity more readily, and it leaks into outer space at a greater rate than other gases. The leakage of hydrogen into space contributes to the shifting of Earth's atmosphere and surface from an initially reducing state to its current oxidizing one. Photosynthesis provided a source of free oxygen, but the loss of reducing agents such as hydrogen is thought to have been a necessary precondition for the widespread accumulation of oxygen in the atmosphere. Hence, the ability of hydrogen to escape from the atmosphere may have influenced the nature of life that developed on Earth. In the current, oxygen-rich atmosphere, most hydrogen is converted into water before it has an opportunity to escape. Instead, most of the hydrogen loss comes from the destruction of methane in the upper atmosphere. Life on Earth. Earth is the only known place that has ever been habitable for life. Earth's life developed in Earth's early bodies of water some 100 million years after Earth formed. Earth's life has been shaping and inhabiting many particular ecosystems on Earth and has eventually expanded globally, forming an overarching biosphere. Therefore, life has impacted Earth, significantly altering Earth's atmosphere and surface over long periods of time, causing changes like the Great Oxidation Event. Earth's life has over time greatly diversified, allowing the biosphere to have different biomes, which are inhabited by comparatively similar plants and animals. The different biomes developed at distinct elevations or water depths, planetary temperature latitudes, and on land, also with different humidity. Earth's species diversity and biomass reaches a peak in shallow waters and with forests, particularly in equatorial, warm and humid conditions. While freezing polar regions and high altitudes or extremely arid areas are relatively barren of plant and animal life, Earth provides liquid water, an environment where complex organic molecules can assemble and interact, and sufficient energy to sustain a metabolism. Plants and other organisms take up nutrients from water, soils, and the atmosphere. These nutrients are constantly recycled between different species. Extreme weather, such as tropical cyclones, including hurricanes and typhoons, occurs over most of Earth's surface and has a large impact on life in those areas. From 1980 to 2000, these events caused an average of 11,800 human deaths per year. Many places are subject to earthquakes, landslides, tsunamis, volcanic eruptions, tornadoes, blizzards, floods, droughts, wildfires, and other calamities and disasters. Human impact is felt in many areas due to pollution of the air and water, acid rain, loss of vegetation, overgrazing, deforestation, desertification, loss of wildlife, species extinction, soil degradation, soil depletion, and erosion. Human activities release greenhouse gases into the atmosphere, which cause global warming. This is driving changes such as the melting of glaciers and ice sheets, a global rise in average sea levels, increased risk of drought and wildfires, and migration of species to colder areas. Human geography. Originating from earlier primates in eastern Africa 300,000 years ago, humans have since been migrating, and with the advent of agriculture in the 10th millennium BC, increasingly settling Earth's land. In the 20th century, Antarctica had been the last continent to see a first, and until today, limited human presence. Human population has since the 19th century grown exponentially to 7 billion in the early 2010s, and is projected to peak at around 10 billion in the second half of the 21st century. Most of the growth is expected to take place in sub-Saharan Africa. Distribution and density of human population varies greatly around the world, with the majority living in South to Eastern Asia and 90% inhabiting only the northern hemisphere of Earth, partly due to the hemispherical predominance of the world's land mass, with 68% of the world's land mass being in the northern hemisphere. Furthermore, since the 19th century, humans have increasingly converged into urban areas, with the majority living in urban areas by the 21st century. Beyond Earth's surface, humans have lived on a temporary basis, with only special purpose, deep underground and underwater presence, and a few space stations. Human population virtually completely remains on Earth's surface, fully depending on Earth and the environment it sustains. Since the second half of the 20th century, some hundreds of humans have temporarily stayed beyond Earth, a tiny fraction of whom have reached another celestial body, the Moon. Earth has been subject to extensive human settlement, and humans have developed diverse societies and cultures. Most of Earth's land has been territorially claimed since the 19th century by sovereign states, countries, separated by political borders, and more than 200 such states exist today, with only parts of Antarctica and few small regions remaining unclaimed. Most of these states together form the United Nations, the leading worldwide intergovernmental organization, which extends human governance over the ocean and Antarctica, and therefore all of Earth. Natural resources and land use. Earth has resources that have been exploited by humans. Those termed non-renewable resources, such as fossil fuels, are only replenished over geological timescales. Large deposits of fossil fuels are obtained from Earth's crust, consisting of coal, petroleum, and natural gas. These deposits are used by humans both for energy production and as feedstock for chemical production. Mineral ore bodies have also been formed within the crust through a process of orogenesis, resulting from actions of magmatism, erosion, and plate tectonics. These metals and other elements are extracted by mining, a process which often brings environmental and health damage. Earth's biosphere produces many useful biological products for humans, including food, wood, pharmaceuticals, oxygen, and the recycling of organic waste. The land-based ecosystem depends upon topsoil and fresh water, and the oceanic ecosystem depends on dissolved nutrients washed down from the land. In 2019, 39 million square kilometers, 15 million square miles, of Earth's land surface consisted of forest and woodlands, 12 million square kilometers, 4.6 million square miles, with shrub and grassland, 40 million square kilometers, 15 million square miles, were used for animal feed production and grazing, and 11 million square kilometers, 4.2 million square miles, were cultivated as croplands. Of the 12 to 14% of ice-free land that is used for croplands, 2 percentage points were irrigated in 2015. Humans use building materials to construct shelters. Humans and the environment. Human activities have impacted Earth's environments. Through activities such as the burning of fossil fuels, humans have been increasing the amount of greenhouse gases in the atmosphere, altering Earth's energy budget and climate. It is estimated that global temperatures in the year 2020 were 1.2 degrees Celsius, 2.2 degrees Fahrenheit, warmer than the pre-industrial baseline. This increase in temperature, known as global warming, has contributed to the melting of glaciers, rising sea levels, increased risk of drought and wildfires, and migration of species to colder areas. The concept of planetary boundaries was introduced to quantify humanity's impact on Earth. Of the 9 identified boundaries, 5 have been crossed: biosphere integrity, climate change, chemical pollution, destruction of wild habitats, and the nitrogen cycle are thought to have passed the safe threshold. As of 2018, no country meets the basic needs of its population without transgressing planetary boundaries. It is thought possible to provide all basic physical needs globally within sustainable levels of resource use. Cultural and historical viewpoint. Human cultures have developed many views of the planet. The standard astronomical symbols of Earth are a quartered circle, representing the 4 corners of the world, and a globus cruciger. Earth is sometimes personified as a deity. In many cultures, it is a mother goddess that is also the primary fertility deity. Creation myths in many religions involve the creation of Earth by a supernatural deity or deities. The Gaia hypothesis, developed in the mid-20th century, compared Earth's environments and life as a single self-regulating organism, leading to broad stabilization of the conditions of habitability. Images of Earth taken from space, particularly during the Apollo program, have been credited with altering the way that people viewed the planet that they lived on, called the overview effect, emphasizing its beauty, uniqueness, and apparent fragility. In particular, this caused a realization of the scope of effects from human activity on Earth's environment. Enabled by science, particularly Earth observation, humans have started to take action on environmental issues globally, acknowledging the impact of humans and the interconnectedness of Earth's environments. Scientific investigation has resulted in several culturally transformative shifts in people's view of the planet. Initial belief in a flat Earth was gradually displaced in ancient Greece by the idea of a spherical Earth, which was attributed to both the philosophers Pythagoras and Parmenides. Earth was generally believed to be the center of the universe until the 16th century, when scientists first concluded that it was a moving object, one of the planets of the solar system. It was only during the 19th century that geologists realized Earth's age was at least many millions of years. Lord Kelvin used thermodynamics to estimate the age of Earth to be between 20 million and 400 million years in 1864, sparking a vigorous debate on the subject. It was only when radioactivity and radioactive dating were discovered in the late 19th and early 20th centuries that a reliable mechanism for determining Earth's age was established, proving the planet to be billions of years old.